Today, we're diving deep to uncover the secrets of one of the planet's most vital yet invisible processes, the biological carbon pump and the true guardians of the deep.
So let's just start with a mind-boggling question. How on earth does the ocean manage to bury a continent's worth of carbon year after year after year? I mean, it sounds like something out of science fiction, right? But it's a real process and it's happening every single day, right beneath the waves.
Well, the answer lies in this remarkable natural engine called the biological carbon pump. And honestly, the best way to picture it is as nature's very own conveyor belt, one that's constantly at work, moving carbon from the air all the way down into the crushing darkness of the deep sea.
So, how does this whole engine even get started? Well, our story begins right at the ocean's surface. Let's get into part 1, the ocean's carbon engine.
The journey kicks off with a step that's actually, surprisingly simple. Carbon dioxide from the atmosphere just dissolves directly into the ocean's surface. It's this natural process of diffusion, and it's even more powerful in colder waters where gases dissolve more easily. This is the gateway for carbon to enter the vast marine world.
Okay, so the CO2 is in the water, but that's just step 1. To really lock it away for good, it needs to be captured by life itself. And that brings us to our next stage, from sunlight to snack.
This is where the real magic happens, in that sunlit top layer of the ocean. They call it the photic zone. These microscopic plants, called phytoplankton, get to work. You can think of them as the invisible forests of the sea. They absorb that dissolved CO2, and through photosynthesis, they convert it into organic carbon, basically their own bodies. Then when tiny animals called zooplankton eat them, that carbon has officially entered the marine food web.
All right, so the carbon has been captured by life. But for this to be a long-term solution, it can't just hang out at the surface. It needs to go down, way down. And that brings us to the next phase, the long plunge downward. And the mechanism for this incredible plunge? Well, it has a surprisingly beautiful name, marine snow.
So what is this stuff really? Marine snow is basically a mix of dead organisms, tiny little fecal pellets from zooplankton, and all sorts of other organic junk. All these bits clump together and start to sink, creating this slow, constant downward blizzard. This is our conveyor belt in action, physically carrying that carbon down into the deep.
And this right here, this is the whole point. This downward movement, as the science says, removes carbon from rapid exchange with the atmosphere. Once it's on its way down, it's effectively taken out of the game, out of the fast lane of the carbon cycle, for a very, very long time.
And when we say a long time, how long are we talking? Well, get this. Once that carbon finally reaches the deep ocean, it can be locked away for hundreds, sometimes even thousands of years. It's an unbelievably effective long-term storage system, all powered by gravity and biology.
But, this whole process isn't just about microscopic life. There are giants at play here, too, and they have a surprisingly powerful role. This brings us to some very unlikely heroes, the guardians of the deep.
It's fascinating because whales actually supercharge this pump in 2 totally different ways. First, you've got the whale pump. This is when they feed deep down, then come back up to the surface and release this nutrient-rich waste. That waste acts like a fertilizer, sparking huge phytoplankton blooms that suck up even more CO2. And then there's the whale fall, which is, well, a lot more direct.
The power of a whale fall is just immense. When a whale dies, its massive, carbon-rich body sinks all the way to the ocean floor. It's like an express elevator delivering a huge payload of carbon directly to the deep sea for storage. A single whale can sequester an amount of carbon that it took decades to build up.
Okay, so we've got this incredible, finely tuned system. It sounds perfect, right? Well, it's not invincible. And our final section looks at the challenges it's facing right now. A pump under pressure.
So why does this matter now more than ever? Because the pump's efficiency is being threatened. Warming waters can slow down the growth of that crucial phytoplankton. Disrupted food webs from things like overfishing can break the carbon transfer chain. And the loss of biodiversity, including those whales we just talked about, it weakens the entire system. Each of these pressures makes the pump less effective. It's like taking gears out of the engine.
So what's the bottom line here? It's this. A hidden engine operating far from sight is absolutely critical for regulating our planet's climate. The biological carbon pump is one of the key reasons our world has been able to stay in a delicate balance for so long.
And that brings us to a final, crucial question.
This deep ocean pump works tirelessly, day in and day out, to keep our world in balance. So, what is our role in protecting it? That's really something to think about. Thanks for joining this explainer.